Now we're going to take a look at the truth value of a conditional statement and also look at related conditional statements. So let's take a look at truth value first. The truth value of a conditional statement is either going to be true or false. In order to show that a conditional statement is true, we just have to show that every time the hypothesis is true, the conclusion is also true. So just every time that P is true, Q is also true, to use our notation there. To show that a conditional is false, however, all we have to do is find one counterexample where when our hypothesis is true, our conclusion is false. So we just have to find one counterexample. Let's take a look at some examples where we are trying to find the truth value of a conditional statement. So for the first one, let's say we're given this statement here. If a woman is French, then she is European. So we're trying to decide if this is true or false. Well, since French means she's from France, and France is in fact a European country, then that means that this statement is true because France is a European nation, so French people are European. For our next example, let's take a look at this statement. If a number is divisible by 3, then it is odd. Well, we want to decide if it's true or false. If it's true, then that means that every time our hypothesis is true, our conclusion is also going to be true, but to show that it's false, we just have to find one counterexample. So let's take a look at this situation where I have 6. 6 is divisible by 3, but 6 is not an odd number. So this is actually a false conditional because we were able to find one counterexample that proved the conditional wrong. Now it's time to practice finding the truth value. Let's take a look at some conditional statements and we'll decide if they are true or false. So our first one, and this was the one that you're going to copy into your notes, is if two angles form a linear pair, then they are supplementary. So your job right now is to copy the statement into your notes, and then you're going to decide if it's true or false. And if it is false, you're going to find a counterexample. So go ahead and pause the video and decide if it's true or false. Now that you've had a chance to work that out on your own, let's go ahead and go over it together. So if two angles form a linear pair, then they are supplementary. So we're trying to decide if this is a true or a false conditional statement. Let's take a look at linear pair here. So a linear pair looks like this. It's two adjacent angles that whose exterior sides, these guys right here, form a straight line. So since this part right here is in fact a straight angle, that means that the measure here is 180 degrees, and the definition of supplementary here is two angles that add together to be 180 degrees. So a linear pair is in fact a pair of supplementary angles. So this is a true conditional statement. Now let's go ahead and take a look at a second problem. So you're going to copy this one into your notes. The statement is, if a month has 28 days, then it is February. So your job right now, you're going to copy the statement into your notes. You're going to decide if it's true or false, and if it is false, you're going to find a counterexample. So go ahead and pause the video and get to work on that. So now that you've had a chance to work on this on your own, we're going to take a look at it together. So our statement was, if a month has 28 days, then it is February. And so we're trying to decide if this is true or false, and if it's false, we're looking for a counterexample. So we do have to be careful with this one. It's kind of tricky, and we have to look at the wording. So this problem says, if a month has 28 days, notice that it does not say only 28 days. It just says if it has 28 days. So I can think of lots of months that have 28 days in them actually. For example, January has 28 days. September has 28 days. In fact, these months have more than 28 days. So this is actually going to be a false statement because I can think of several counterexamples where there is a month that has 28 days that is not February. If we were dealing with a statement that said if a month has only 28 days, then we might be examining a different case. We're going to take a look now at how to negate a statement. So the negation of a statement is the opposite of the statement. So the symbol that we use for that, in keeping with our notation before, is we do kind of a little squiggle and then P, and this is read as not P. So it's the opposite of whatever statement we have. So for example, if our statement was the sky is blue, the negation of the statement is the sky is not blue. The reason that we use negations is we can use them to write statements related to a conditional statement, and every conditional statement has 3 related conditional statements, and those types of related conditional statements are the converse, the inverse, and the contrapositive. And right now we're going to take a look at what each of those looks like. So to get to the converse of a conditional statement, all that we have to do is exchange the hypothesis and conclusion. So if our original statement is if P, then Q, then all I have to do to write the hypothesis, or the converse, is going to be write if Q, then P. Let's take a look at an example of this. So going back to the example that I used from the previous video, our conditional statement, if I am Peter Pan, then I can fly. Well, originally, if I am Peter Pan was the P, it was our hypothesis, and then I can fly was our conclusion, it was the Q. So to turn this into the converse of this statement, I would just swap my P and my Q here, and so this would become if I can fly, then I am Peter Pan. And notice that all I did was, if I can fly, this was my Q, then I am Peter Pan, this was my P. I just swapped them, and so that is how we get to the converse. Our next related conditional statement is the inverse of a statement, and so all we have to do to find the inverse is to negate both the hypothesis and the conclusion of our statement. So if we remember, the negate just means say not. So we just say not the hypothesis, then not the conclusion. So to use our notation from before, I would say if not P, then not Q. Let's take a look at our example from before. So if I am Peter Pan, then I can fly. So my P is I am Peter Pan, and my Q is I can fly. So all I'm going to do to write the inverse of this is I'm going to add in not to my P and my Q. And so then I will rewrite that as if I am not Peter Pan, then I can not fly. So all I did was, this was my P, this was my hypothesis, this was my Q, this was my conclusion, and all I did was add in not to both my hypothesis and my conclusion, and I have created the inverse. Let's take a look at our final related conditional statement, and that is the contrapositive. So all that we're going to do to form the contrapositive is we're going to negate both the hypothesis and the conclusion of the converse. So that's a really big phrase for we switch the hypothesis and conclusion and we negate them both. So we say not to both of them. So to use our notation, if my original notation is if P, then Q, then what I'm going to do is I'm going to switch them. So my Q is going to come first so that I make the converse, and then my P is going to come second, and then I'm going to negate them both. So using my little squiggle symbol, so I started out, my original statement was if P, then Q, and so my contrapositive is going to be if not Q, then not P. Taking a look at our same example again, if I am Peter Pan, then I can fly. We're trying to make the contrapositive of this, so our steps are to negate the hypothesis and the conclusion of the converse. So I switch my hypothesis and my conclusion, and I make them both not. So in my statement, if I am Peter Pan, that's my hypothesis, then I can fly, that's my conclusion. So my job is to switch these two and negate them both. So when I rewrite that as the contrapositive, it's going to say, if I can not fly, then I am not Peter Pan. So, to recap, what I did here was, this was my P here. This was originally my hypothesis. Now it's my conclusion, and I've negated it. And this was originally my conclusion. I can fly. But now it's my hypothesis, and I have negated it. So the contrapositive of if I am Peter Pan, then I can fly. The contrapositive of that is if I cannot fly, then I am not Peter Pan. Okay, so now using the information that we've learned, we're going to try to write some related conditional statements. So this is going to be the part that you put in your notes. So if I give you the conditional statement, if the measure of angle A equals 15, then angle A is acute. So your job right now is to copy this statement down into your notes, and then you're going to write out the converse, the inverse, and the contrapositive. So go ahead and pause the video and work on that. Now that you've had a chance to work on it on your own, let's go ahead and take a look at it together. So our original conditional statement was, if the measure of angle A is 15 degrees, then A is acute. So first we're going to try to write the converse, and that is where we just switch the hypothesis and conclusion. So my hypothesis is measure of angle A is 15, and my conclusion is A is acute. So if I rewrite this now, I'm going to switch my P and my Q. I'm going to switch my hypothesis and my conclusion. So I'm going to say, if angle A is acute, then the measure of angle A is 15. Okay, so now we're going to take a look at our inverse. And that is where we negate both the hypothesis and the conclusion. So I'm going to take my hypothesis, I'm going to make it not, I'm going to take my conclusion, and I'm going to make it not. So then when I rewrite this, it's going to be, say, if the measure of angle A does not equal 15, then angle A is not acute. And notice that I just used a little bit of mathematical shorthand here. I just crossed out the equal symbol, so I didn't have to write out the whole phrase. I just said measure of angle A is not 15. Okay, so now taking a look at our last one, the contrapositive. So the contrapositive of my conditional statement is going to be, I'm going to switch my hypothesis and my conclusion, and I'm going to negate them both. I'm going to make them both not. So if I rewrite that, it's going to look like this. If angle A is not acute, then the measure of angle A does not equal 15.